Pluto drifts quietly at the far edge of our solar system, a small, icy world sitting in a region of space so distant that the Sun appears as little more than a very bright star from its surface. It moves slowly through the dark, following a long, unhurried path through a part of the solar system called the Kuiper Belt, where countless other small bodies drift in a similar stillness. There is nothing urgent about Pluto. It has been out there for billions of years, moving at its own gentle pace, far beyond the familiar planets, in a place where space is wide and quiet and very, very cold. Pluto was discovered in the year 1930, found by a young astronomer named Clyde Tombaugh who was working at the Lowell Observatory in Arizona. He had been given the careful, patient task of comparing photographs of the night sky, looking for anything that had moved between one image and the next. It was methodical, unhurried work. Night after night, photograph after photograph, he looked. And then one day in February, he found something. A tiny point of light had shifted slightly against the background of stars. That faint, shifting point was Pluto. It was a quiet discovery, made through patience and careful attention, which seems fitting for such a quiet and distant world. After it was found, the question of what to name it was open to suggestions from around the world. Many names were proposed. A young girl in England named Venetia Burney suggested the name Pluto, after the Roman god of the underworld, a realm that was dark and distant and beneath the world of the living. The name felt appropriate for something so far from the warmth of the sun. It was adopted, and the small, icy body has been called Pluto ever since. There is something peaceful about that name now. It has settled into it over the decades, and it suits the world it belongs to. Pluto. Dark. Distant. Quietly itself. Pluto sits in the Kuiper Belt, a broad region of space that begins beyond the orbit of Neptune and extends outward for a great distance. The Kuiper Belt is home to many small, frozen objects, remnants from the early formation of the solar system. These objects never came together to form a larger planet. Instead, they have remained as they were, drifting slowly in the cold outer regions of the solar system for billions of years. Pluto is one of the largest of these objects, though even so, it is quite small by the standards of the planets closer to the Sun. The Kuiper Belt is not a place of drama or turbulence. It is simply a wide, cold region of space, filled with small frozen worlds moving in slow, long orbits around the distant Sun. If you are still awake, simply let these thoughts drift through your mind like something floating on still water. There is no need to hold on to any of it. Just let the words come and go gently. Pluto is small. It is smaller than our own moon, which is itself not particularly large in the grand scheme of things. Its diameter is roughly 2,370 kilometers, which sounds like a significant number until you place it alongside the Earth, which is nearly 6 times wider. Pluto fits into the solar system quietly, without taking up much space. It is not trying to be large. It simply is what it is, a compact, frozen world, settled comfortably into its small size. There is something restful in thinking of a place that makes no claims to grandeur, that simply exists in its own humble dimensions, far from everything else. The surface of Pluto is covered largely in ice. Not the kind of ice you might find on a winter morning, but ice is made of nitrogen, methane, and carbon monoxide, substances that exist as gases closer to the Sun but freeze solid in Pluto's extreme cold. Temperatures on Pluto hover somewhere around -220°C, which is extraordinarily cold. The landscape is shaped by this cold, slowly and over very long periods of time. Nitrogen ice flows in ways that resemble glacier, moving gradually across the surface. Methane ice frosts certain regions, giving parts of the surface a reddish or tan hue. The ground is textured by these ices in patterns that are gentle and slow, shaped by processes that take place over thousands or millions of years. Nothing on Pluto happens quickly. There is a large, pale region on Pluto's surface that has become one of its most recognized features. It is shaped, quite naturally and without any particular design, like a heart. This pale region is a vast plain of nitrogen ice, smooth and bright compared to the darker terrain around it. It has been given the informal name Tombor Regio, in honor of Clyde Tombaugh, the astronomer who discovered Pluto. The heart shape is simply the way the ice has settled and spread across that part of the surface, a coincidence of geography and chemistry. From a distance, viewed in images sent back from spacecraft, it looks soft and luminous, a pale marking on a small, cold world. It is a quiet feature. It does not demand attention. It is simply there, resting on the surface of Pluto the way frost settles on a cold window. The terrain of Pluto is varied in a way that was not fully appreciated until a spacecraft traveled close enough to observe it in detail. There are mountain ranges made of water ice, which, at Pluto's temperatures, is as hard and rigid as rock. Some of these mountains rise several kilometers above the surrounding plains. There are also areas of darker, more reddish material, and regions where the surface appears to have been shaped by some ancient, slow geological activity. There are what appear to be dunes, formed not by wind and sand but by particles of methane ice moved by the very thin atmosphere. Everything about these features speaks of slowness, of processes unfolding over immense spans of time in a place where there is no rush, no urgency, no force demanding that anything happen quickly. Pluto has a very thin atmosphere, which appears and fades in a gentle cycle as Pluto moves closer to and farther from the Sun in its long orbit. When Pluto is at the part of its orbit closest to the Sun, some of the surface ice sublimates, meaning it passes directly from solid to gas without becoming liquid first. This creates a thin haze around the planet, a delicate atmospheric layer of nitrogen and other gases. The atmosphere is so thin it would be entirely undetectable to human senses standing on the surface, yet it is there, a faint presence surrounding the small world. As Pluto moves away from the Sun again, this atmosphere slowly freezes back onto the surface. It is a cycle that plays out over decades, quiet and unhurried. If your eyes are growing heavy, that is a gentle and welcome feeling. There is nothing here that needs your full attention. These words can simply flow around you, soft and steady. Pluto's orbit around the Sun is one of its most distinctive qualities. Unlike the roughly circular orbits of the inner planets, Pluto follows a path that is noticeably elliptical, stretched out into an oval shape. This means that at some points in its orbit, Pluto is significantly closer to the Sun than at others. Its closest point to the Sun, called perihelion, actually brings it closer than Neptune for a period of time, while its farthest point, called aphelion, takes it much deeper into the outer solar system. One full orbit of Pluto around the Sun takes approximately 248 Earth years. That means a single Pluto year is longer than all of recorded human history. Pluto moves at its own vast, unhurried pace, circling the Sun in a rhythm that has nothing to do with human timescales. Another quiet detail about Pluto's orbit is that it is tilted relative to the flat plane in which most of the planets travel. Pluto's orbital path tips up at an angle, carrying it above and below the main plane of the solar system as it moves. This tilt, combined with its elliptical path, gives Pluto an orbit that feels independent, moving to its own rhythm in the far reaches of space. It is neither perfectly aligned with the other planets nor entirely separate from them. It simply follows its own long, tilted, oval path in the quiet outer dark. Pluto also rotates slowly on its axis. A single day on Pluto, from one sunrise to the next, lasts approximately 6.5 Earth days. The Sun would rise very slowly on Pluto, moving in a gradual arc across a sky that is dark even during the day, because the Sun, though brilliant, is so far away that it provides only a fraction of the light and warmth it gives to Earth. Standing on Pluto's surface, you would see a tiny, intensely bright point of light in a dark sky, surrounded by stars. It would feel more like a clear night on Earth than a sunny day. The sky would be a deep blue at certain times, tinted by the haze of the thin atmosphere, and quite dark at others. It would be a still and silent place, cold and clear and very, very far from everything else. Pluto is not alone in its journey through the outer solar system. It has moons, 5 of them known to us, each one small and quiet in its own way. The largest of these moons is called Charon, and it is remarkable for how large it is relative to Pluto itself. Charon is roughly half the diameter of Pluto, which makes it proportionally one of the largest moons in the solar system relative to the body it orbits. Because of this size relationship, Pluto and Charon orbit around a point that lies in the space between them rather than deep inside Pluto. They move around each other, a pair of worlds locked in a slow, mutual dance in the dark. Charon's surface is quite different from Pluto's. Where Pluto is covered in pale nitrogen ice and colorful organic compounds, Charon's surface is made largely of water ice and appears more gray and muted in tone. There is a large, dark reddish region near Charon's north pole that has been given the informal name Maunder Macula. This dark region is thought to be formed by gases escaping from Pluto's atmosphere and settling onto Charon's surface, where they are transformed by radiation from the Sun into darker organic compounds. It is a quiet, slow process, taking place over millions of years in the cold space between two small, distant worlds. Charon and Pluto are tidally locked to each other, meaning they each always show the same face to the other. They rotate at the same rate that they orbit each other, so from Pluto's surface, Charon always appears in the same place in the sky, never rising or setting, simply hanging there, large and still. And from Charon, Pluto would appear the same way, fixed and quiet in the dark sky above. It is an arrangement of perfect stillness between the two worlds, each one always facing the other across the space between them. Pluto's other 4 moons are smaller and have their own quiet qualities. Nix and Hydra were discovered in 2005, and Kerberos and STYX were found later using the sharp eyes of the Hubble Space Telescope. These smaller moons are tiny and irregular in shape, tumbling slowly as they orbit around the Pluto-Charon system. They are not large enough to have settled into smooth spherical shapes. They are simply small, uneven chunks of ice and rock, drifting in slow orbits in the dim light of the distant sun. They ask for no attention, and they receive very little. They are simply there, part of a small, quiet system at the edge of the solar system. If sleep is drawing near, let it come. These words will continue softly, and you can drift as you listen, or simply rest in the stillness. For many decades after its discovery, Pluto was classified as the 9th planet of the solar system. It was the outermost known planet, the final member of a familiar sequence that began with Mercury and ended with this small, cold world in the distant dark. But over time, astronomers began discovering other objects in the Kuiper Belt that were of similar size to Pluto. One object in particular, now known as Eris, turned out to be very close to Pluto in size, and for a time was thought to be even larger. This raised a question that had to be considered carefully. If Pluto was a planet, then perhaps Eris should be one too, and perhaps many other Kuiper Belt objects would need to be considered as well. In 2006, the International Astronomical Union, the body responsible for defining and categorizing astronomical objects, established a formal definition for the term planet. Under this definition, a planet must orbit the Sun, must have enough mass that its own gravity has pulled it into a roughly spherical shape, and must have cleared the neighborhood around its orbit of other debris. Pluto meets the first two conditions but not the third. The Kuiper Belt is full of other objects in the region of Pluto's orbit, and Pluto does not have the gravitational dominance to have cleared that space. As a result, Pluto was reclassified into a new category called Dwarf planet, a category that also includes Eris, Ceres, Makemake, and Haumea. This reclassification is simply a matter of definition, a way of organizing our understanding of the solar system more precisely. Pluto itself did not change. It continued on its long orbit, cold and quiet, entirely unaffected by the conversations and decisions taking place on a small warm planet many billions of kilometers away. It is still the same world it has always been, the same icy surface, the same thin atmosphere, the same slow rotation, the same heart-shaped plane of nitrogen ice. The category it belongs to is simply a human way of describing it, and human ways of describing things are always open to revision as understanding grows. Pluto rests in its dwarf planet classification as it rests in everything, quietly and without complaint. Another gentle detail is that even though Pluto is a dwarf planet, it is considered the largest known dwarf planet in the Kuiper Belt. Eris, though close in size, is slightly smaller in diameter, though it is more massive because it is denser. The distinction between the two is subtle and small. Both are distant, cold, quiet worlds in the outer solar system, drifting slowly in the dark. Whether one is slightly larger than the other in one measurement or another makes very little difference to the vast, still space in which they both travel. The most significant event in our direct knowledge of Pluto came in July of 2015, when a spacecraft called New Horizons made its closest approach to Pluto after a journey of 9.5 years. New Horizons was launched in January of 2006, setting out from Earth on a long, careful path toward the outer solar system. It traveled at remarkable speed, faster than any spacecraft before it, and yet even at that speed, the journey to Pluto took almost a decade. That is simply how far away Pluto is. New Horizons passed closest to Pluto on the 14th of July, 2015. In those hours, it gathered an enormous amount of data and imagery, transmitting back to Earth the first close-up views of a world that had previously appeared only as a fuzzy blur in even the most powerful telescopes. The images revealed a surface of extraordinary detail and variety. Mountain ranges, smooth plains, dark regions, bright regions, the heart-shaped Tombor Regio. Features that had not been guessed at, textures and structures that spoke of a complex, active geology even in that cold and distant place. The data from New Horizons took more than a year to fully transmit back to Earth, because Pluto is so far away that even radio signals, traveling at the speed of light, take more than 4 hours to make the journey. Each image, each measurement, each piece of information arrived slowly, a trickle of discovery stretched out over many months. Scientists and engineers waited patiently for each transmission, and each one added a little more to the picture of what Pluto is really like. It was a slow unfolding, fitting for a world that does everything slowly. After its encounter with Pluto, New Horizons continued onward into the Kuiper Belt, visiting a smaller object called Arrokoth in January of 2019. Arrokoth is a contact binary, two small lobes that formed separately and then came together very gently over time, now resting against each other in a shape that is sometimes described as a snowman. New Horizons passed Arrokoth even more closely than it had Pluto, and again gathered images and data that revealed a quiet, undisturbed surface that had remained almost unchanged since the earliest days of the solar system. New Horizons is still traveling outward, moving deeper into the Kuiper Belt and eventually into the space beyond, sending back whatever data its instruments can gather as it goes. If you are still with these words, let them continue to settle around you like something very soft and very still. There is no need to follow closely. Simply let the sound of the words be a companion as you rest. Pluto is about 5.9 billion kilometers from the Sun on average, though this distance varies considerably over the course of its long orbit. To put that in some kind of gentle perspective, Earth is about 150 million kilometers from the Sun. Pluto is roughly 40 times farther from the Sun than Earth is. At that distance, the Sun provides about 1/1000th of the light and warmth it provides to Earth. The surface of Pluto receives enough sunlight to be faintly illuminated but nothing more. There is no warmth in it. The ground remains frozen, the ices remain solid, and the thin atmosphere remains nearly imperceptible. It is a world of perpetual, quiet cold. The light from the Sun, traveling at the speed of light, takes about 8 minutes to reach Earth. To reach Pluto, that same light takes more than 5 hours. When you look at an image of Pluto, you are seeing it as it was 5 hours before the light left it and began its long journey toward any camera or telescope pointed in its direction. Everything you learn about Pluto, you learn with a delay of 5 hours or more. It is already a little in the past by the time any information about it reaches you. There is something very calming in that thought. The way distance creates a kind of gentle softness in time, the way news from very far away always arrives a little late, a little faded by the journey. The Kuiper Belt that Pluto calls home is named after a Dutch-American astronomer named Gerard Kuiper, who proposed in the 1950s that a region of icy bodies might exist beyond the orbit of Neptune. He was not entirely correct in his predictions, but his thinking pointed in the right direction, and so the region carries his name. The Kuiper Belt extends from about 30 astronomical units from the Sun, which is roughly the distance of Neptune's orbit, to about 50 astronomical units. 1 astronomical unit is the average distance between the Earth and the Sun. So the Kuiper Belt spans a significant portion of the outer solar system, a wide, cold ring of small icy bodies drifting in the dark. The objects in the Kuiper Belt are thought to be remnants from the formation of the solar system, material that never coalesced into a larger planet. In the inner solar system, this kind of material came together over time through gravity and collision to form the rocky planets, including Earth. In the outer solar system, the distances were greater, the material more spread out, and the process slower and less complete. Jupiter's enormous gravity may have played a role in disrupting the formation of a larger body in this region. Whatever the reasons, the material remained as small, separate objects, and the Kuiper Belt is where many of them have drifted ever since. Among the quiet details of Pluto's world is the way its surface shows evidence of geological change, which was unexpected for such a small, cold, distant body. Before New Horizons arrived, many scientists expected Pluto's surface to be uniformly ancient and cratered, unchanged for billions of years. What they found instead was a surface with regions of dramatically different ages. Some areas are indeed heavily cratered and ancient. But the smooth plains of the Tombor Regio appear to be geologically young, with very few craters, suggesting that the surface there has been renewed relatively recently in geological terms, perhaps only a few tens of millions of years ago, which is quite recent when you consider that the solar system is about 4.5 billion years old. What drives this geological activity on such a small, cold world is not fully understood. There may be processes involving the movement of nitrogen ice, which flows slowly like a glacier under its own weight, filling in craters and smoothing the surface over time. There may be internal heat remaining from the formation of the solar system, or from the decay of radioactive elements deep within Pluto. Whatever the cause, the surface of Pluto is not simply a frozen, unchanging landscape. It is a place where slow, quiet processes continue to operate, reshaping the terrain on timescales that are immense by human standards but brief by geological ones. Another quiet detail is the color of Pluto. When New Horizons sent back its images, Pluto appeared in soft shades of reddish-brown and pale yellow, with bright white regions of fresh nitrogen ice. The reddish colors come from organic compounds called tholins, which form when methane is exposed to ultraviolet radiation from the sun. These compounds give the surface a warm, muted palette that is quite different from the stark white one might imagine for such a cold world. Pluto is subtle in its coloring, gentle and varied, a landscape of quiet tones rather than bold contrasts. The North Pole of Pluto has a distinctive cap of methane ice that gives it a slightly different appearance from the surrounding terrain. Seasonal changes on Pluto, stretched out over its very long year, cause the pattern of frost and ice on the surface to shift slowly over time. Nitrogen and methane move from one part of the surface to another as Pluto travels through its orbit, freezing in some places and sublimating in others. These changes happen over decades and centuries, too slowly to observe directly from Earth, but the patterns left on the surface record a history of slow, patient change. If sleep is very close now, Simply let go. These words are soft and there is nothing here that needs your attention. Let your breathing slow and your thoughts drift away from the words and into the quiet. Pluto's axis is tilted dramatically, more than any of the major planets except Uranus. Pluto is tilted about 120 degrees relative to its orbit, which means that during different parts of its long year, different regions of its surface experience continuous sunlight or continuous darkness for decades at a time. Near the poles, there can be periods of many Earth decades when the sun never sets, followed by equally long periods of total darkness. These long polar days and nights drive slow changes in the distribution of ice and frost across the surface. It is a world of extremes spread across enormous timescales, where seasons last for decades and a single year stretches longer than all of recorded human civilization. The relationship between Pluto and Charon continues to hold its quiet fascination. Charon is so large relative to Pluto that the two are sometimes called a double dwarf planet system rather than a planet and its moon. They are bound together by gravity, always facing each other, always maintaining their slow, shared orbit around the common point between them. From one hemisphere of Pluto, Charon would always be visible, enormous and gray in the dark sky. From the other hemisphere, Charon would never be visible at all, permanently hidden beyond the horizon. It is a permanent arrangement, fixed over the lifetime of the solar system, two small worlds in a quiet, mutual embrace across the cold dark between them. Hydra and Nix, Pluto's two next largest moons, move in orbits that are related to each other and to Charon's orbit in a way that is mathematically orderly. The ratios of their orbital periods are close to simple whole numbers, a pattern called an orbital resonance. This kind of resonance is a common outcome of gravitational interactions over long periods of time. It is a form of order that emerges slowly from the gentle tugging of gravity, the solar system quietly arranging things into simple, stable relationships over billions of years. The surfaces of Nix and Hydra are thought to be composed largely of water ice, reflecting light rather efficiently and appearing relatively bright. Because they are so small and so far from Earth, very little detail can be seen in even the best images we have of them. They are simply small, bright points in the images returned by New Horizons, irregular in shape, tumbling slowly in their orbits. They are modest companions to Pluto, unassuming and quiet, adding their small presence to a system that is itself modest and quiet. The discovery of Pluto's smallest moons, Kerberos and Styx, came as something of a surprise. They were found using the Hubble Space Telescope in preparation for the New Horizons mission, and their existence was not expected. They are very small, and they appear darker than Nix and Hydra, which is itself something that scientists have found interesting and somewhat puzzling. Why would some of Pluto's moons be bright and others dark? The answer may have to do with differences in composition or with how their surfaces have been affected by various processes over time. These are questions that may take many more years and perhaps further missions to answer fully. For now, they are simply quiet mysteries, resting in the dark at the edge of the solar system. The question of how Pluto's moon system formed is one that scientists continue to think about carefully. The most widely considered explanation is that the moons formed from debris thrown out when Pluto was struck by another large Kuiper Belt object very early in the solar system's history. This collision, if it happened, would have been an event billions of years ago, long before any living thing existed on Earth. The debris from that ancient event settled into orbit around Pluto and Charon, gradually coming together to form the smaller moons. It is a quiet history, preserved in the arrangement of small moons drifting around a small world in the cold outer dark. Another gentle thought is that Pluto was the first Kuiper Belt object to be discovered, and it has held that distinction for the longest time. The Kuiper Belt itself was not confirmed observationally until 1992, when the first other Kuiper Belt object beyond Pluto was found. In the decade since, thousands of Kuiper Belt objects have been catalogued, and it has become clear that Pluto is simply the largest and most well-known member of a vast family of small, icy worlds. It is not alone out there. It has many neighbors, most of them much smaller and most of them completely unknown to the general awareness of the world. They drift in their slow orbits, unnamed and unvisited, in the cold outer regions of the solar system. If you are still listening, that is perfectly all right. Let the words continue their slow, steady movement through your mind, like the current of a very still river. Pluto has been the subject of considerable affection since its reclassification as a dwarf planet. Many people felt a kind of fondness for it as the outermost planet, a small and distant member of the solar system family, and the change in its status prompted genuine sentiment in many quarters. This human response to an astronomical category change is itself a quiet, interesting thing. We had given Pluto a place in our mental picture of the solar system, had included it in our lists and our models and our understanding, and when the category changed, it felt like a small loss to some. Pluto, of course, remained entirely unchanged. It continued its long orbit in the cold dark, indifferent to the naming conventions of a small planet many billions of kilometers away. But the feeling speaks to how we form attachments to the places we learn about, even places we will never see and can only barely observe. The New Horizons spacecraft, after its encounter with Pluto and Arrokoth, is continuing outward through the Kuiper Belt. It carries with it instruments that continue to measure the environment of the outer solar system, the density of dust, the character of the solar wind, the properties of the region through which it passes. It is a small, quiet traveler, moving through the dark at remarkable speed, sending back data that helps us understand a part of the solar system that we have barely begun to explore. Eventually, New Horizons will pass through the outer boundary of the solar system and continue into interstellar space, where it will drift silently for an unimaginably long time. Pluto itself will continue its long orbit, as it has for billions of years. Over the next roughly 160 years, it will complete the remainder of its current orbit and return to the position it occupied when it was discovered in 1930. From there it will begin another circuit, another 248 years of slow, steady travel around the distant Sun. The nitrogen ice on its surface will shift with its slow seasons. Its thin atmosphere will come and go as it approaches and recedes from the Sun. Charon will continue its quiet orbit, always facing Pluto, always present in the sky above one hemisphere. The small moons will continue their tumbling paths. Everything will continue as it has continued, slowly and without interruption, in the cold and quiet dark. There are future missions to the outer solar system that scientists and engineers have thought about and proposed, missions that might return to Pluto or visit other Kuiper Belt objects. Such a mission would require many years of travel, and planning and building it would require many years before that. These things move slowly, as perhaps is appropriate for exploring a part of the solar system where everything moves slowly. Whether or not such a mission happens, the knowledge gathered by New Horizons has transformed our understanding of Pluto from a vague, fuzzy point of light into a detailed and complex world, and that transformation is permanent. The images are there, the data is recorded, and Pluto is known more fully now than it was before. The distance of Pluto from the Sun places it in a region where the solar wind, the stream of particles that flows outward from the Sun, is weak and stretched thin. The solar wind has traveled so far by the time it reaches the Kuiper Belt that its influence is greatly diminished. The environment out there is quieter, less energetic, shaped more by the cold and the dark than by the activity of the Sun. It is a different kind of space from the busy inner solar system, where planets, moons, and asteroids are more numerous and the Sun's influence is strong. The outer solar system is spacious and still, a wide, dark expanse where things are spread far apart and the silence, metaphorically speaking, is very deep. Light from distant stars is more clearly present in the outer solar system, not because the stars are any closer, but because there is less competing light from the Sun to wash them out. Standing on Pluto's surface, the sky would be full of stars, brilliant and steady in the airless cold. The Milky Way would arch overhead, a broad band of light made of billions of distant suns, each one far beyond the reach of any spacecraft we have ever built or imagined building. The view from Pluto's surface would be a view into the depths of the galaxy, a quiet, magnificent darkness filled with ancient light. It is a place that invites contemplation of large things, of distances and timescales that are simply too vast for the mind to hold completely, and that vastness is itself something to rest in rather than struggle with. Pluto's discovery came at a moment in human history when the solar system was still a largely mysterious place. Astronomers could observe planets and their moons through telescopes, but the detail available was limited. The outer planets were known largely through their gravitational effects on other bodies and through careful but distant observation. Pluto appeared only as a point of light. Its size, its surface, its moons, its atmosphere, its geological character, all of these remained essentially unknown for the 75 years between its discovery and the launch of New Horizons. 75 years of knowing that something was there without knowing what it truly was, only that it was small, cold, distant, and quietly present in the outer dark. The patience required to wait 75 years for a close look at a world is significant. It reflects something about the pace at which our understanding of the solar system has grown and the patience that science requires. Knowledge about distant things comes slowly, in small increments, over long periods of time. New Horizons itself took 9.5 years to travel to Pluto. The planning and building of that spacecraft took many years before its launch. The analysis of the data it gathered has continued for years afterward. Understanding Pluto is a slow, patient process, entirely in keeping with the character of the world being studied. Let your breath come and go slowly. There is no hurry here. These words will simply continue, soft and steady, and you can let your mind drift wherever it wishes to go. Pluto has a density that is intermediate between ice and rock, suggesting that its interior is made of a mixture of both, with a rocky core surrounded by a mantle of ice. Some scientists have proposed that there may be a liquid water ocean deep within Pluto, beneath the ice mantle, kept from freezing by the decay of radioactive elements in the rocky core. This is not certain, but it is a possibility that the data from New Horizons does not rule out. The idea of a liquid ocean hidden beneath the icy surface of a small, cold world at the edge of the solar system is one of those quiet surprises that the solar system occasionally offers, a reminder that the universe is more varied and more interesting than our initial expectations. Whether or not Pluto has a subsurface ocean, it is a world that is more geologically active than its small size and extreme cold might suggest. The evidence for relatively young surfaces, for flowing nitrogen ice, for ongoing processes of one kind or another, all point to a world that is not simply a frozen, inert relic of the solar system's early history. It is a place where things continue to happen, slowly and quietly, over the long timescales that govern all processes so far from the Sun. The way Pluto has been studied illustrates something about how we come to understand distant things. First, there is discovery, the recognition that something is there. Then there is observation, the gathering of whatever information can be extracted from the available data. Then there is inference, the careful reasoning from incomplete data about what cannot be directly seen. And then, if we are fortunate, there is a close encounter, a moment when a spacecraft travels close enough to gather direct observations and the picture becomes suddenly much clearer and more detailed. Each of these stages contributes something, and each requires patience and careful attention. The knowledge that exists now about Pluto is the result of all of these stages, unfolding over nearly a century of slow, patient inquiry. Another quiet detail is that Pluto's name was once proposed for other purposes before it was applied to this distant world. Pluto had been used in mythology and in other contexts, but in the context of the solar system, it now belongs entirely to this one small, cold world drifting in the outer dark. The name has a fitting quality to it, 3 syllables that end softly, a word that feels a little distant and a little quiet, appropriate for the world it names. And the name carries within it the first 2 letters of the name Percival Lowell, the astronomer who had predicted the existence of a planet beyond Neptune and at whose observatory the search that led to Pluto's discovery was conducted. Clyde Tombaugh made the discovery at Lowell Observatory, working in the tradition of Lowell's prediction, and the name Pluto carries that history quietly within it. The history of the search for Pluto began with the observation that the orbits of Uranus and Neptune did not quite match the predictions that astronomers had made based on the known gravitational influences on those planets. This discrepancy led to the suggestion that another planet might exist farther out, its gravity tugging gently on the outer planets and causing those small deviations. Percival Lowell devoted significant resources to searching for this hypothetical planet, which he called Planet X. He did not find it during his lifetime. The search continued after his death, and eventually Clyde Tombaugh found Pluto. Later analysis suggested that Pluto was far too small to have caused the orbital discrepancies that motivated the search, and that those discrepancies may have been the result of observational errors rather than an unknown planet. But the search continued anyway, and Pluto was found, even if it was not exactly what had been sought. The story of Pluto's discovery is in some ways a story about the value of careful, patient searching even when the original premise turns out to be inexact. Tombaugh was not looking for Pluto specifically. He was looking for something that could cause certain gravitational effects, something much larger than Pluto turned out to be. But in the process of that careful searching, he found something real and genuinely interesting, a world that has occupied our curiosity and our affection ever since. That is often how discovery works, not as a straight line from question to answer, but as a meandering path that leads to places not exactly anticipated. Pluto continues on its path. The Sun, from its surface, is a very bright star in a dark sky. Charon hangs fixed in the sky above one hemisphere, enormous and still. The surface is cold and quiet, shaped by the slow movement of ice and the gradual effects of radiation over billions of years. The thin atmosphere comes and goes with the long seasons. The small moons drift in their tumbling orbits. And in the darkness and cold of the Kuiper Belt, among countless other small icy worlds, Pluto moves along its long oval path at its own unhurried pace. There is something restful about a world that simply exists in that way, without drama or urgency, in a place so far from everything busy and loud. Pluto does not need our attention. It has been there for billions of years, and it will continue to be there for billions more. It asks nothing of us. It simply drifts, cold and quiet, at the edge of the known solar system, a small and distant world carrying its pale heart-shaped plane of nitrogen ice out through the dark. If you are still awake, simply let the quietness of that image rest with you. A small world, far away, moving slowly through the cold dark of the outer solar system, turning its pale face toward a sun too far away to warm it, accompanied by its large gray moon and its small tumbling companions, existing in the stillness and the dark the way it has always existed, the way it will always exist, quietly and without need of anything beyond the slow, steady gravity that keeps it on its path and the cold that keeps it frozen and the dark that surrounds it on all sides, vast and still and full of stars. Let that image be the last thought of the night if it wishes to be. A small, quiet world, very far away, drifting slowly through the dark. And here, much closer, warmth and rest and the soft weight of sleep, drawing everything gently downward into stillness.